I'm Anil Kumar sharing questions from previous test papers. Here is the one which is on even and odd functions. The question is, question number 3. Without graphing, determine if each polynomial function has line symmetry about the y-axis, point symmetry about the origin, or neither. We are given two functions. You can pause the video, copy these, answer the question, and then look into my suggestions. Now here is my copy of the question. It says, without graphing, determine if each polynomial function has a line symmetry about y-axis, point symmetry about origin, or neither. Let us understand what is line symmetry about y-axis. If a function has line symmetry about y-axis, it really means that the function is even, right? So this means even function. So this, let me write down here even, and that means that f of minus x should be same as f of x. That is what it means, correct? Now let us also understand what does it mean by point symmetry, right? So point symmetry about origin. It means that the function is odd and f of minus x is equals to minus of fx. That is the meaning, correct? Now once we know the meaning and we understand, let's try to prove whether these functions are even, odd, or neither, or whether they have line symmetry about a y-axis, point symmetry about origin, or neither, right? So let me begin with the very first one. When you investigate f of x equals to 2x to the power 4 minus 5x squared plus 3, since each term is even, you expect it to be even, so it will be even. Now I'll prove it algebraically. So to prove algebraically, we have to find what is f of minus x. Replace x with minus x. So we get 2 times minus x to the power of 4 minus 5 minus x squared plus 3, right? Now that gives you, minus power is always positive, so we get 2x to the power of 4 minus 5x squared plus 3, and this is exactly same as the function itself. So what we notice here is, since f of minus x is equals to f of x, the function has symmetry about y-axis, right? The other way of saying the same thing is that the function is even. Okay, so sometimes you may be asked even or odd functions. So we have done the first part. Now let's look into the part B. I hope you understand the process. You can actually pause the video now, answer, and then check your solution. So now we'll again find what is g of minus x. G of minus x will be minus 3 minus x to the power of 5 plus 9 times minus x cubed plus 2 times minus x. Now negative x to the power of 5 will be negative. That negative times this makes it positive. So we get 3 times x to the power of 5 plus times minus is minus 9x cubed, and here we get minus 2x. Now we can take minus common. So if I take minus common, I'm left with minus 3x squared, 3x to the power of 5. This becomes plus 9x cubed, and here we have minus becomes plus, so we have plus 2x. Okay, now that gives you, inside function is same as g of x, so we can write this as minus g of x. Now since g of minus x is equals to minus g of x, it has point symmetry, right? So it has point symmetry about origin, right? About origin, let me write 0, 0. And in other terms, we say it is odd function. Is it okay? Odd symmetry. It has, this function has odd symmetry. Let me call odd symmetry. It has odd symmetry. So that's another way of saying it. But I hope with this you understand how to prove it algebraically. Thank you and all the best.